Okay, so we have already seen the classification learner app. Now we are going to see how we can use deep network designer app that is available for uh, deep learning neural network models. Now, usually these models are used for images. So for doing that, I have selected one image data set. Now, basically, this image data set consists of two groups, that is healthy control group and schizophrenia group. So I have collected the EEG signal for both the groups, and it that EEG signal usually actually consists of 19 channels, and I have converted that 19 channel 180 seconds EEG of each person in the form of image, that I have called as time series EEG image. So let me show you a sample of image data set. So in order to understand how we have created this image and how it will be able to classify the image. So yes, so basically this is one sample image that you can see in your screen. This one sample image consists of 10 seconds of EEG signal simultaneously taking 19 channels at a time. So this complete section or this width represents the first channel, second width represents the second channel, third, fourth, fifth, and so on. So overall 19 different width segment you can see that consists of 19 channels, and here the y-axis shows the duration of that signal. So basically it consists of 10 seconds of EEG, and while recording we have taken 256 hertz of sampling frequency. So this image consists of 2560 instances or samples, you can say. So this is one first image that I have labeled as H1, that is healthy control 1. So basically what we have done, we have created images for all the samples, all the patients and healthy control group, and we have saved these images in two subfolders, that is HC and SC, and these subfolders are saved in one complete folder, that is I closed image, that you can see here. Okay, so I'm going to classify these two groups of images. So for that, first I have to open my Matlab window. Again, in the topmost segment you can see the application part available. So you have to click on this app section, and after selecting the app section you have to select which application you are going to select. So in this case, I'm going to select the deep network designer application, which comes under the machine learning and deep learning toolbox. So when you click on this, again, it takes a little time in order to launch the application, as it is a huge application. It consists of many 50 to 100 deep learning pre-trained models available in this application. It has residue network with 50 layer, 100 layer, 18 layer. It has Google Net, LXNet, and number of pre-trained deep learning models which are used for classification of images are available in this. Other than this, we have a number of audio pre-trained networks available in this deep learning network model. So I think it is getting launched right now, this application window. Okay, now it has been launched, and once it is started, one more window popped up to you, that is Deep Network Designer start page. And let me introduce you about this page. So in this page, you can develop your own network by clicking on this blank network, or as I said, there are a number of pre-trained networks available in this application. So once we click more networks, you can see the Squeeze Net, Google Net, Residue Network, Efficient Net, Dark Net with different layers like 53, 19, Shuffle Net, and a number of networks available in this. For image, that is pre-trained network. It is trained with thousand number of images and tested with that. Also, we have some sequence network. Here you can see some exclamation mark. It is for the reason that I have installed some of the network in this, and I have not installed a few networks. So if you want to use a specific network, you can install that network, and automatically you will get the architecture of that network. Similarly, for sequence dataset, we have sequence network. For audio dataset, we have different audio networks available. So let us begin the demonstration with ResNet 50. It is one of the most popular network. It is basically less complex, and it is little bit fast. So that's why we are using this network as compared to other networks, I'm saying. So but usually it also takes a long time in order to overall process the data. So once you import the residue network, the complete architecture will be imported in the form of a block diagram that is connected with each block. A number of convolution layer is there, and all other deep network layers are available in this. Okay, so now the ResNet pre-trained model with 50 layers is now imported. So these are overall architectures. So in order to see the proper view of this architecture, let me zoom this block. Okay, so this one is the first layer, that is input layer. So here we are taking image as input. So this basically shows the input image size which we have taken. In case we are taking a sequence input, so in order to that we have to change the layers accordingly. So in the left hand side you can see the different layers, activation functions, classification model. Each block is there, so you can use this block in order to modify the available networks or to develop your own networks. So these are the complete layers of a ResNet 50 model. Now let's look at the last few layers. In the last third layer, it is a fully connected layer that has an output size of 1000. Uh, Basically, what I have told you that this model is trained to classify 1000 different classes of images. So here we are doing the binary classification. We are classifying the two groups of images, that is healthy control group and schizophrenia group. So in order to perform this, we have to change this fully connected layer, and we will replace this fully connected layer with another layer that consists of only two filters. So let me drag a new fully connected layer here. Simply we can drag and drop this layer, and just a second. And after this I will delete the previously available layer and replace this with the new layer and make the connections accordingly. Okay, now here you have to set the output size. So we are performing the binary classification. So I'm selecting the output size as 2. Now, similarly, here the classification output size is again 1000. So I will replace this classification block with a new classification block that consists of two classes. So first, let me delete this block and I will replace with new classification layer, and I will make the according connection. Okay, so here automatically the output size will be selected. Okay, now this ResNet model is modified as per our need. We have changed the output class size. Now let's move to the data section. After designing your network, you have to select your data. So first we have to import the data. So you have to click on this import image classification data. Okay, so once you click, another window popped up, that is import image classification data. So you have to select the data source, either if you have stored your data in workspace, or it is in the form of folder. So here it is in the form of folder saved in my desktop. So I have to browse that folder from my desktop or laptop. So this is the folder I closed image original. So let me select this folder. So it also provides the augmentation option also. So right now I'm not going for to perform any augmentation here, because it will again take a large time. Further, it allows me to decide the training and validation data set. So I can directly split the data from my training data itself, which is from Holter, or I can also save a different folder for testing. So for validation, you can say. So right now I'm doing the splitting of data from my existing folder only, and in order to perform convenient and fast process, let me divide the data in 10 and 90%. So 10% of data will be used for validation, and 90% will be used for training. Also, we can select this 10% randomized, or we can take in any order like that. So let me randomize this data and import the data. Okay, so now the data is imported by this application. Here you can see the training data set consists of 648 healthy control and 648 schizophrenia group. And overall, it consists of 1296 observations that consist of two classes. And similar for validation also, we have taken 10% of validation data set. So here we have some 70 to 72 observations for validation in case of healthy control and in case of schizophrenia group both. So after performing this, importing the data, we will go to the training section of this application. So in the training section, we can directly start the training, or we have to tune the or change the hyperparameter uh, and training options as per our need. So this training options, or you can say the proper selection of training options, decides the overall training time and validation time, as well as the performance of your model. Uh, we have to select the uh, best trade-off between the uh, complexity and speed of the model and the accuracy of our model. So, in order to run this process in a faster way, we have to select a minimum batch size as less as possible. Okay, so here you can see a multiple training options available, like which solver you're using, SGDM, ADAM, and any other. You have to change, you can change the learning rate, batch size, etc. So usually a larger batch size takes a longer time for training and testing. So let me reduce this to 16, and other hyperparameter tuning option is also available here. So let me leave it as a default and just change the minimum batch size to the 16. And now simply you have to click on to OK. Okay, now after selecting this, simply you have to click on to train model. And from here, your training will be started.